Section 4.2 is about combining functions and composite functions. And we're going to start with operations on functions. And every time I hear operations on functions, I always think of that board game Operation. And so I've given you a picture of that just so you can get some insight into how my brain works. I've also gone ahead and taken the green box from our book on page 263 and transferred that to our page here so we can talk about the sum, the difference, the product, and the quotient operations on functions. As you can see in the sum operation on functions, it's going to read f plus g of x, and the way we're going to read it as f of x plus g of x. The difference is f minus g of x, and we're going to read it as f of x minus g of x. The product is f times g of x, and we're going to read that as f of x times g of x. And finally, the quotient, which is f divided by g of x, and we're going to read that as f of x divided by g of x, provided, of course, that g of x does not equal 0, because you cannot divide by 0. We've talked about that several times this semester. All right, so let's look at example 1 on page 263 and see if we can put this in order. Let's go ahead and get operation out of here. We don't need that thing anymore. Example 1 says if f of x is equal to x cubed, let's put that in here, and g of x equals x minus 1, then find the following functions and give their domains. All right, part A has f plus g of x. And remember, the way we're going to interpret that is f of x plus g of x. And because our f of x is x cubed, that means we have x cubed, plus our g of x, I'm going to go ahead and put that in a parenthesis to keep it straight, is x minus 1. And then I ask myself, hey, is there any meaningful way I can combine these other than losing the parentheses? And the answer is no. There's no meaningful way to combine these. There's no like terms to combine. And so our answer is going to be simply x cubed plus x minus 1. We move on to B. We're going to have f minus g of x. Again, we want to interpret that as f of x minus g of x. The difference here is, from the first one, that we're having a minus between them. So our f of x is x cubed minus. It's important to use the parenthesis this time to keep them straight, because this parenthesis delineates that this negative applies to all the things in the parenthesis. So we're going to have x cubed. We're going to have minus times x, minus x. And minus times minus 1, that's plus 1. And then again, if at this point we could combine these, if there were any like terms to combine, we'd want to do so. But as you can see, there are no like terms here. X cubed is not like x, not like 1. So this is going to be the final answer here. Again, let me stress, it's important to have this parenthesis right here with the negative sign. It implies that everything in the parenthesis gets the negative sign. And without the parentheses, you might miss that. All right, part C, we've got f times g of x here, which means f of x times g of x. So in our case, that means x cubed times x minus 1. So we're going to have x cubed times x in our case, which is x to the 4th power, and x cubed times negative 1, that's going to be minus x cubed. And there's nothing more to combine there. If there were like terms, we definitely want to combine things too, but there are no like terms here to combine, and so it's x to the 4th minus x cubed. Our final one we move into for this particular example is f divided by g of x, which means f of x divided by g of x. Our f of x, once again, is x cubed. Our g of x is x minus 1. And again, if there was any way for us to simplify these, we would do so. But we can't, so this is as good as it's going to get. Now, there's one part of this question we hadn't answered yet for A, B, and C, and D, and that is to give the domains of all these functions. And so for a domain, what we're looking for is there any restriction on x? Is there anything x can't be in any of these problems as far as us putting a value in there? So for instance, if we look here at part D first, there's only one value x cannot be, and it comes from the denominator. X cannot be 1, because if x was 1, we'd have 1 minus 1, and we'd have 0 in the denominator. We just can't have that. So our domain is restricted on part D, but if you look again at parts A and B and C, there are no restrictions to what X can be. So for A and B and C, the domain is everything. We like to call that negative infinity to positive infinity if we use interval notation. But for D, the interval is going to be, for the domain, negative infinity to positive 1 and positive 1 to positive infinity. Basically a long and fancy way of saying everything but 1.